In a world full of surface-level stories, we go deeper. Welcome to The Depth, your destination for facts, science, history, and mysteries that shape our world. Let's begin the journey, deeper than ever before. Hey everyone, and welcome back to the channel where we explore the biggest questions in the cosmos. Today, we're taking a journey through the mind-boggling scale of the universe and the galaxies that call it home. So, grab your imaginary spaceship, buckle up, and let's get started. Our story begins a long, long time ago. About 13.8 billion years ago to be precise. That's when the universe as we know it burst into existence. Since then, it's been expanding and evolving, creating structures on a scale that's almost impossible to comprehend. Think about this for a moment. Go to any beach, pick up a handful of sand, and try to count the grains. It's a futile task, right? Well, scientists estimate there are more stars in the observable universe than there are grains of sand on every single beach and desert on our entire planet. Just let that sink in. Each of those stars could potentially have its own system of planets, its own worlds. The sheer number is staggering. And where do all these stars live? In galaxies, of course. Our own cosmic home is the Milky Way, a beautiful spiral galaxy containing hundreds of billions of stars, including our Sun. But as vast as the Milky Way is, it's just one drop in an enormous cosmic ocean. Astronomers estimate there are over 200 billion galaxies in the observable universe. Some are spirals like ours, others are massive elliptical blobs, and some are irregular and chaotic. It's like a cosmic city, with galaxies as the neighborhoods. And almost every single one of these galactic neighborhoods has a monster lurking in its downtown area. I'm talking about supermassive black holes. These are objects with gravitational pulls so strong that not even light can escape, and they have masses millions or even billions of times that of our Sun. Our own Milky Way has one at its center, called Sagittarius A. These behemoths play a crucial role in how galaxies form and evolve, acting as a sort of gravitational anchor. Now, you might feel a little small and isolated out here in our corner of the Milky Way. But we do have neighbors. Our closest major galactic neighbor is the Andromeda Galaxy. It's a magnificent spiral, even bigger than our own, and it's located just 2.5 million light-years away. I say just because in cosmic terms, that's practically next door. To put it in perspective, the light we see from Andromeda tonight left that galaxy 2.5 million years ago, when early human ancestors were first walking the Earth. And here's where it gets really interesting. Andromeda isn't just sitting there. It's hurtling towards us at a speed of about 110 kilometers per second. Don't panic and start building a bunker just yet, but our two galaxies are on a collision course. In about 4 billion years, the Milky Way and Andromeda will begin a spectacular slow-motion merger. It'll be a cosmic dance that will reshape both galaxies, eventually forming a new, giant elliptical galaxy. Our solar system will likely be thrown into a completely new region of this new galaxy. It's an event that will light up the future night sky for any civilization that might be around to see it. You might be imagining a chaotic cosmic pileup, with stars crashing into each other like a demolition derby. But the amazing thing is, that's not what happens. The space between stars is so incredibly vast that when two galaxies like the Milky Way and Andromeda merge, it's almost certain that not a single pair of stars will physically collide. Instead, the galaxies will pass through each other like two ghosts. Their stars will be flung around by the immense gravitational forces. Their orbits will be scrambled, but the stars themselves will remain intact. It's a gravitational ballet on a galactic scale. This brings us to another common misconception, that space is empty. When we look up at the night sky, we see stars separated by what appears to be a black, empty void. But that couldn't be further from the truth. Space is actually teeming with stuff. We just can't see most of it. It's filled with gas, dust, radiation, and a whole lot of invisible matter. This is where we get into some of the biggest mysteries in modern physics. All the stars, planets, galaxies, and everything we can see and interact with, what we call normal matter, makes up less than 5% of the total mass and energy of the universe. So, what's the other 95%? Well, about 27% of the universe is made of something called dark matter. We know it's there because we can see its gravitational effects. It's the invisible scaffolding that holds galaxies and clusters of galaxies together. Without dark matter, galaxies would fly apart. Their stars would be moving too fast to be held by the gravity of the visible matter alone. But we have no idea what dark matter actually is. It doesn't emit light, it doesn't reflect light, and it doesn't seem to interact with normal matter in any way other than through gravity. It's one of the most profound puzzles in science today. And if that wasn't strange enough, the remaining 68% of the universe is even more bizarre. It's something we call dark energy. Back in the late 1990s, astronomers were trying to measure how much the expansion of the universe was slowing down due to gravity. But to their complete astonishment, they found the exact opposite. The expansion of the universe isn't slowing down at all. It's accelerating. Something is pushing everything apart, acting like a sort of anti-gravity. We've named this mysterious force dark energy, but honestly, we have almost no clue what it is. It seems to be a property of space itself, meaning that as space expands, more of this energy appears, pushing the expansion to go even faster. This discovery was so revolutionary, it won the Nobel Prize. It completely changed our understanding of the ultimate fate of the universe. Instead of collapsing back in on itself in a big crunch, it seems the universe is destined to expand forever, becoming colder, darker, and emptier as galaxies are pushed further and further apart from each other. Imagine vast, beautiful clouds of dust and gas floating in space. These are called nebulae, and they are the cosmic nurseries where stars are born. Gravity slowly pulls clumps of this material together, they get hotter and denser, and eventually, a star ignites. It's a process that has been happening for billions of years, creating every single star you see. And speaking of stars, let's talk about our very own star, the Sun. It might seem huge to us, but on a cosmic scale, it's actually classified as a medium-sized yellow dwarf star. It's been shining for over 4.6 billion years, and it's the undisputed king of our solar system. Get this. The Sun accounts for an incredible 99.8% of all the mass in our solar system. That means everything else, all the planets, moons, asteroids, and comets, makes up just a tiny 0.2%. It's the ultimate celestial powerhouse. Now, how does the Sun produce all that light and heat? It's a nuclear fusion reactor. Every single second, the Sun converts a staggering 600 million tons of hydrogen into helium. This process releases an enormous amount of energy, which travels through space and makes life on Earth possible. It's been doing this consistently for billions of years, and it has enough fuel to keep going for about another 5 billion years. So, no need to worry just yet. But our Sun is just one type of star. The universe is filled with all sorts of exotic and extreme stellar objects. One of the most fascinating is the neutron star. These are the incredibly dense remnants left behind after a massive star explodes. How dense are they? Well, if you could take just a single teaspoon of material from a neutron star, it would weigh a mind-boggling 1 billion tons. That's heavier than all the cars on Earth combined, squeezed into a teaspoon. It's almost impossible to wrap your head around that level of density. Here's another cool fact that might surprise you. You know how stars seem to twinkle in the night sky? That beautiful shimmer isn't actually coming from the stars themselves. If you were an astronaut in space, you'd see stars as steady, unwavering points of light. The twinkling effect is caused entirely by Earth's atmosphere. As starlight travels down to us, it passes through different layers of air with varying temperatures and densities, which bend the light back and forth, making it appear to twinkle. It's a beautiful illusion created by our own planet. Let's talk about color. When you look at stars, you might notice some have a slightly different hue. This color is a direct clue to their temperature. You might intuitively think that red means hot and blue means cool, like with a water tap. But in the world of stars, it's the complete opposite. The hottest, most massive stars burn with an intense blue light, while the coolest, smaller stars glow with a reddish hue. Our yellow sun sits comfortably in the middle of this temperature spectrum. So, stars are born. They live for billions of years. But what happens when they die? The end of a star's life can be one of the most spectacular events in the universe. For very massive stars, their death is a violent and brilliant explosion known as a supernova. When a supernova goes off, it can momentarily outshine an entire galaxy. Imagine that, a single dying star releasing more light than hundreds of billions of other stars combined. This incredible brightness can last for several weeks, and the explosion scatters heavy elements created inside the star across space, providing the raw materials for new stars, new planets, and even for us. These supernova explosions are incredibly important. The iron in your blood, the calcium in your bones, the oxygen you breathe. Nearly all the elements heavier than hydrogen and helium were forged in the hearts of stars and then distributed throughout the cosmos by these cataclysmic events. In a very real sense, we are all made of stardust. It's a humbling and beautiful connection we share with the universe. From the swirling dust of nebulae to the brilliant death of a supernova, the life cycle of a star is a truly epic story. They are the engines of the cosmos, the creators of elements, and the silent witnesses to the universe's long history. The next time you find yourself under a clear, dark sky, take a moment to really look up. Think about the immense distances, the incredible power, and the ancient light that has traveled for years, sometimes millions of years, just to reach your eyes. Each star has a story, and together they make up the grand, beautiful tapestry of our universe. Imagine a world with absolutely no atmosphere to protect it. That's Mercury. It's constantly being bombarded by intense solar radiation. There's no air to breathe, no clouds to shield it, just a barren, cratered surface exposed to the raw power of our star. Temperatures here are extreme, swinging from over 800 degrees Fahrenheit on the sunny side, hot enough to melt lead, down to a frigid minus 290 degrees on the dark side. It's a world of incredible contrast, a testament to the harsh realities of space right next door to our sun. Next up, we visit Earth's so-called twin, Venus. But let me tell you, this twin is anything but identical. For starters, Venus has a serious rebellious streak. While most planets, including Earth, spin counterclockwise, Venus spins backward, or clockwise. Scientists think a massive collision in its distant past might have literally knocked it upside down. And if that's not strange enough, get this. A single day on Venus is longer than its entire year. It takes Venus 243 Earth days to complete one rotation, but only 225 Earth days to orbit the Sun. You'd celebrate your birthday before a single day-night cycle was over. It's a slow, backward world trapped under a crushing, toxic atmosphere. Definitely not a vacation spot. And that brings us home, to the third rock from the Sun, our beautiful Earth. Out of all the billions of celestial bodies we've observed, this is the only one we know for certain has life. From the deepest oceans to the highest mountains, life has found a way to thrive here. Our planet sits in the Goldilocks zone, that perfect distance from the Sun where water can exist as a liquid, creating the ideal conditions for the incredible diversity of life we see all around us. We have a protective atmosphere, a magnetic field, and a delicate balance of elements that make it all possible. It's a precious, living oasis in the vastness of space, and it's the only home we've got. So far, at least. The search for life elsewhere continues, but for now, Earth stands unique. Let's hop over to our rusty red neighbor, Mars. This planet is famous for its reddish hue, caused by iron oxide, basically rust, on its surface. But Mars holds a record that truly towers over anything on Earth. It's home to the largest volcano in the entire solar system, Olympus Mons. This isn't just a big mountain, it's a colossal shield volcano that's nearly 16 miles high. That's almost 3 times the height of Mount Everest. Its base is so wide that if you were standing at the edge of its caldera, the slope would be so gradual that you wouldn't even realize you were on a massive volcano. Olympus Mons is so huge it practically pokes out of the thin Martian atmosphere, a truly monumental feature on a world that continues to fascinate us. Now, prepare to be humbled as we journey to the king of planets, Jupiter. This gas giant is in a league of its own. It's so massive that all the other planets in our solar system could fit inside it, with room to spare. To give you some perspective, you could fit over 1/300 Earths inside Jupiter. It doesn't even have a solid surface like the rocky planets. It's a swirling, chaotic ball of hydrogen and helium. Its famous Great Red Spot is a storm that has been raging for centuries, a storm larger than our entire planet. Jupiter is like a mini solar system all on its own, with dozens of moons, powerful magnetic fields, and an intimidating presence that has protected the inner planets, including Earth, from countless asteroids and comets. It truly is the giant guardian of our solar system. Continuing outward, we arrive at the jewel of the solar system, Saturn. Everyone knows Saturn for its breathtaking rings, but what are they actually made of? You might imagine them as solid, spinning disks, but they're not. Saturn's rings are mostly composed of billions upon billions of chunks of water ice with some rocky material and dust mixed in. These particles range in size from tiny grains of dust to massive chunks as big as a house. This spectacular ring system is incredibly thin, in most places less than 100 feet thick, despite stretching out for thousands of miles. It's a delicate, shimmering halo of ice, orbiting a beautiful gas giant. It's a reminder that even in the vast cold of space, there is incredible, fragile beauty. Our next stop is a real head-scratcher, Uranus. This ice giant is the oddball of the solar system. While other planets spin more or less upright like spinning tops, Uranus is tilted on its side. Its axis is tilted at a staggering 98 degrees, which means it essentially rolls around the sun. Imagine a planet where one pole faces the sun for decades, experiencing a 42-year-long summer, while the other pole is plunged into a 42-year-long, dark winter. This extreme tilt gives it the most bizarre seasons imaginable. Scientists believe that, like Venus, a giant impact early in its history might have knocked it over. Whatever the cause, Uranus is a planet that plays by its own rules, spinning through space unlike any other. If you think hurricanes on Earth are powerful, they are nothing compared to the weather on Neptune. This deep blue ice giant has the fastest, most ferocious winds ever recorded. Supersonic winds whip through its atmosphere at speeds of over 1,200 miles per hour, or 2,000 kilometers per hour. That's faster than the speed of sound. These incredible winds are a mystery, as Neptune is so far from the sun and receives very little energy. Yet, it generates these mind-bogglingly powerful storms, including a massive dark spot similar to Jupiter's Great Red Spot. It's a turbulent, stormy world at the far edge of our planetary family. For decades, Pluto was our 9th planet, the small, icy outpost at the edge of the solar system. While its status changed in 2006, it remains a fascinating world. And here needs a fact to put its size into perspective. Pluto is actually smaller than our own moon. That's right, the former planet that captured the world's imagination is tiny. Its diameter is less than the distance from London to Moscow. But don't let its size fool you. The New Horizons mission showed us that Pluto is a complex and active world, with vast plains of nitrogen ice, towering mountains of water ice, and a thin, hazy atmosphere. It's proof that even the smallest worlds in our solar system can hold the biggest surprises. From a day that's longer than a year to volcanoes 3 times taller than Everest, our solar system is packed with wonders. First up, did you know the moon is slowly ghosting us? It's true. Every year, it drifts about 3.8 centimeters further away from Earth. That might not sound like much, but over billions of years, it adds up. Imagine this. Back in the day, the moon was much, much closer. And a closer moon meant monster tides. We're talking colossal waves hundreds of meters high, sloshing across the planet. It's a good thing it's moved a bit further away, right? Have you ever noticed that the man in the moon always looks the same? That's not a coincidence. The moon is tidally locked with Earth, which means it rotates on its axis at the exact same speed it orbits our planet. The result? We only ever get to see one side of it from down here. It's like the moon has a permanent good side for all its photos with Earth. The other side, the far side, remained a complete mystery until we sent spacecraft to check it out. Speaking of space missions, let's talk about something the Apollo astronauts discovered that you can't experience from Earth: the smell of the moon. That's right, the moon has a smell. When astronauts returned to their lunar module after a moonwalk, they brought fine gray dust back with them. Once they took their helmets off in the pressurized cabin, they noticed a distinct aroma. They described it as smelling like spent gunpowder or wet ash in a fireplace. It's a sharp, metallic, and pungent scent caused by charged particles from the sun hitting the lunar soil. And here's another shocker. The moon isn't completely dry. For a long time, we thought it was a barren, waterless desert. but recent missions have confirmed the presence of water ice tucked away in permanently shadowed craters near the Moon's poles. These are areas that haven't seen sunlight in billions of years, making them cold enough to preserve ice. This discovery is huge because water is a critical resource for future lunar bases. It could provide drinking water, breathable oxygen, and even rocket fuel. Now, you know about earthquakes, but have you ever heard of moonquakes? They are a real phenomenon. The Moon isn't as geologically dead as we once thought. These quakes are generally milder than the ones on Earth, but they happen. Some are caused by the gravitational pull of the Earth squeezing and stretching the Moon, others by meteorite impacts, and some deep quakes seem to originate from far within the Moon's interior. Seismometers left by the Apollo astronauts detected thousands of these tremors during their operational time. And speaking of the Apollo missions, those iconic first steps have left a lasting legacy. The footprints left by Neil Armstrong and Buzz Aldrin in 1969 are still there, perfectly preserved. How is that possible? The Moon has no atmosphere, which means no wind or rain to erode them away. They are like a cosmic monument, sitting undisturbed for over 50 years. Barring a direct meteorite strike, those footprints could remain there for millions of years, a silent testament to one of humanity's greatest achievements. So, where did the Moon even come from? The leading theory is as dramatic as a Hollywood blockbuster. It's called the Giant Impact Hypothesis. The idea is that about 4.5 billion years ago, a Mars-sized object, which scientists have nicknamed Theia, slammed into a young, molten Earth. The collision was so immense that it blasted a huge chunk of Earth's mantle into orbit. This debris eventually coalesced, pulled together by gravity, and formed the Moon. So, in a very real sense, the Moon is a piece of our own planet. It's Earth's child, born from a cataclysmic event. This shared origin story helps explain some things, but the Moon still has its mysteries, like its two-faced nature. Remember how we only see one side? Well, the far side is surprisingly different from the near side we're all familiar with. The crust on the far side is significantly thicker and more rugged, with far fewer of the large dark plains, or maria, that make up the face of the man in the Moon. Scientists are still debating why this is. One idea is that the heat radiating from the still hot Earth, shortly after the giant impact, kept the near side of the Moon molten for longer, allowing for a thinner crust to form. A day on Earth is 24 hours. A day on the Moon, it's a little bit longer. A full lunar day from one sunrise to the next lasts about 29.5 Earth days. That means you'd experience roughly 2 weeks of continuous, scorching daylight, followed by 2 weeks of frigid, unending darkness. The temperatures swing wildly, from over 120 degrees Celsius in the sun to below minus 170 degrees Celsius in the dark. So, if you're ever planning a lunar vacation, make sure you pack for all seasons, all at once. From its slow retreat and strange smell to its secret water and violent birth, the Moon is so much more than just a light in the sky. It's a dynamic, complex world with a rich history and a future intertwined with our own. Imagine something so powerful, so intense, that nothing, and I mean nothing, can escape its grasp. Not a spaceship, not a planet, not even light itself. This is why they're called black holes. They're the ultimate cosmic prisons. Light travels faster than anything else in the universe, yet once it crosses a black hole's point of no return, known as the event horizon, it's trapped forever. It's like a one-way door to infinity. Speaking of infinity, let's talk about time. We all experience time as a constant forward march, right? Well, near a black hole, that all changes. Thanks to Einstein's theory of general relativity, we know that massive objects can warp the fabric of spacetime. A black hole's gravity is so extreme that it slows down time itself. If you could hover safely near the edge of a black hole and then return to Earth, you would find that years, or even centuries, have passed for everyone else while only a short time passed for you. It's real-life time travel, but with a very strange and dangerous twist. Now, you might be thinking, okay, that's terrifying. But are any of these things near us? The good news is, you can sleep soundly tonight. The nearest known black hole, a system named Gaia BH1, is about 1/1600 light-years away from Earth. To put that into perspective, 1 light-year is almost 6 trillion miles, so while it's the closest one we've found, it's still an unimaginable distance away. There's absolutely no danger of our solar system getting pulled into one. It's a cosmic neighbor, but a very, very distant one. Black holes come in different sizes, but some are true cosmic giants. Meet the supermassive black holes. These behemoths can be millions, or even billions of times more massive than our own sun. Scientists believe that nearly every large galaxy, including our own Milky Way, has a supermassive black hole at its center. Ours is called Sagittarius A, and it's about 4 million times the mass of the Sun. These giants are the gravitational anchors of their galaxies, playing a crucial role in how stars and galaxies form and evolve. They are the true kings of the cosmos. What's more incredible than one black hole? Two, of course. Sometimes galaxies collide, and when they do, their central supermassive black holes can get caught in a gravitational dance. They begin to orbit each other in a pair known as a binary black hole system. Over millions of years, they spiral closer and closer together, spinning faster and faster. This cosmic waltz is one of the most powerful and energetic events in the universe, and it leads to something truly spectacular, which we'll get to in just a moment. Let us address the ultimate what-if scenario. What if you fell into a black hole? The outcome is as strange as it is grim. As you approach the black hole, the gravitational pull on the part of your body closest to it would be much stronger than the pull on the part farthest away. This difference in gravitational force would stretch you out, thinner and thinner, like a piece of spaghetti. This process has a scientific name, and it's perfectly descriptive: spaghettification. It's a bizarre and final end to a journey into the unknown. Remember those binary black holes we talked about? Their cosmic dance doesn't last forever. Eventually, they merge into one, even larger black hole. This collision is so violent that it sends ripples through the very fabric of space-time. These ripples are called gravitational waves. For a long time, they were just a prediction of Einstein's theory, but in 2015, scientists detected them for the first time, confirming another piece of his genius. Listening to these waves allows us to hear the echoes of cosmic collisions that happened billions of years ago. It's a brand new way to observe the universe. For decades, black holes were purely theoretical. We could see their effects on nearby stars and gas, but we had never actually seen one. That all changed in 2019. The Event Horizon Telescope, a global network of radio telescopes working together, captured the first-ever direct image of a black hole's shadow. The image was of the supermassive black hole at the center of the M87 galaxy, 55 million light-years away. It was a monumental achievement. A glowing ring of superheated gas circling a region of pure darkness, finally giving us a face to the mystery. There's a common misconception that black holes are like cosmic vacuum cleaners, sucking up everything in their path. That's not quite right. A black hole is just an object with a lot of gravity. It pulls things in the same way the sun pulls on the Earth. If you were to magically replace our sun with a black hole of the exact same mass, Earth and the other planets would continue to orbit it just as they do now. We wouldn't get sucked in. You have to get very, very close to a black hole to be captured by its pull. They don't hunt, they just wait. What is the ultimate fate of a black hole? Do they last forever? The famous physicist Stephen Hawking proposed that they don't. He theorized that black holes can slowly evaporate over immense timescales through a process now called Hawking radiation. Tiny particles are thought to pop into existence at the event horizon, and sometimes one escapes while the other falls in, effectively carrying away a tiny bit of the black hole's mass. This process is incredibly slow. For a solar mass black hole, it would take trillions upon trillions of years, far longer than the current age of the universe, to disappear completely. So, while they might not be eternal, they are about as close to it as anything can get. From bending time to creating ripples in space-time, black holes are truly some of the most fascinating objects out there. They challenge our understanding of physics and remind us just how vast and awe-inspiring our universe really is. Now, let's go back to April the 12th, 1961. This was the day humanity first dipped its toes into the cosmic ocean. A 27-year-old Soviet cosmonaut named Yuri Gagarin strapped himself into the Vostok 1 capsule, and blasted off. For 108 minutes, he orbited our planet, becoming the very first human to see Earth from space. Can you imagine the view? Seeing our world not as a map with borders, but as a single beautiful blue marble floating in the dark. His famous words upon launch were Poyakali, which means, let's go. And with that simple phrase, the space age truly began. He proved it was possible. He opened the door for every astronaut and every mission that followed. Just 8 years later, humanity took an even bigger leap. On July 20th, 1969, the world held its breath as Neil Armstrong descended the ladder of the Apollo 11 lunar module. As his boot touched the dusty surface of the moon, he uttered those immortal words, "That's one small step for a man, one giant leap for mankind." He and Buzz Aldrin spent about 2.5 hours walking on another world, a place humans had only dreamed of visiting for millennia. It was a monumental achievement, a testament to human ingenuity and our relentless desire to explore the unknown. From Gagarin's first orbit to Armstrong's first step, it was a sprint of incredible progress. Now, let's fast forward to the present day. High above our heads, traveling at a blistering 17,500 miles per hour, is the International Space Station, or ISS. This incredible orbiting laboratory is the size of a football field and has been continuously inhabited by astronauts since the year 2000. Because at ES moving so fast, the ISS circles the entire Earth every 90 minutes. This means the astronauts on board get to see 16 sunrises and 16 sunsets every single day. Imagine watching the world glide by beneath you, seeing continents and oceans, storms and city lights, all in a single, silent, spectacular loop. It's the ultimate window seat. Life on the ISS is anything but ordinary. One of the weirdest side effects of living in space is that you actually grow taller. Here on Earth, gravity is constantly compressing our spine. In the microgravity environment of space, your vertebrae can spread apart a little, and astronauts can grow up to 2 inches taller. The effect is temporary, though. Once they return to Earth and gravity takes hold again, they shrink back down to their normal height within a few months. It's a bit like being stretched out and then squished back into place. Speaking of microgravity, let us talk about a concept that's hard to wrap your head around. There's no up or down in space. Without the constant pull of gravity telling our bodies which way is down, our sense of orientation gets all mixed up. Astronauts float inside the space station, and any wall can be the floor, and any ceiling can be a wall. They call it free fall. It's like constantly falling, but you never hit the ground because you're moving sideways so fast that you keep missing the Earth. This is why you see them effortlessly tumbling and spinning in videos from the ISS. They have to retrain their brains to navigate a three-dimensional world where directions are relative. While we've been busy exploring our immediate cosmic neighborhood, we've also sent out robotic explorers to the farthest reaches of our solar system and beyond. The most famous of these is NASA's Voyager 1 probe. Launched way back in 1977, its original mission was to study Jupiter and Saturn. But after it finished that, it just kept going. In 2012, Voyager 1 officially crossed into interstellar space, becoming the first human-made object to leave our solar system. It's now over 15 billion miles away from us, sailing through the void between the stars. On board is the Golden Record, a sort of time capsule containing sounds and images of Earth, a message in a bottle for any intelligent life that might find it millions of years from now. It's a tiny, lonely ambassador from humanity, carrying our story into the vast cosmic darkness. To look even deeper into space is to look back in time. The most powerful tool we have for this is the James Webb Space Telescope. Launched in 2021, this incredible observatory is like a time machine. Light travels at a finite speed, so when we look at distant objects, we're seeing them as they were when the light first left them. The James Webb Telescope is so powerful it can detect the faint, ancient light from the very first galaxies that formed after the Big Bang, over 13 billion years ago. It's literally showing us pictures of the universe's infancy, helping us piece together the story of how everything we see today came to be. Each image it sends back is a postcard from the dawn of time. Let's bring it back a little closer to home. What does space actually smell like? This sounds like a trick question, since you can't take your helmet off to sniff. But astronauts have reported a very distinct smell that clings to their suits and equipment after a spacewalk. They describe it as a mix of seared steak, hot metal, and welding fumes. Scientists think this smell is caused by high-energy vibrations in particles brought back inside, or perhaps reactions with oxygen in the airlock. It's the scent of atomic oxygen, a reminder that the vacuum of space isn't entirely empty. It's filled with strange and reactive elements. So, you want to go on a spacewalk and smell it for yourself? Well, you'll need a suit, and they don't come cheap. A modern NASA spacesuit, which is officially called an extravehicular mobility unit, is a masterpiece of engineering. It's not just a set of clothes, it's a personal, human-shaped spacecraft. It provides oxygen, temperature control, radiation shielding, and protection from micrometeoroids. It even has a built-in drink bag and a waste collection system. All that technology comes at a price. A single suit costs around $12 million. So next time you see an astronaut floating outside the ISS, remember they're wearing one of the most expensive and complex outfits ever made. The Sun. The Sun is about 93 million miles away. That's a huge distance, and even though light is the fastest thing in the universe, it still takes time to travel. Specifically, it takes sunlight about 8 minutes and 20 seconds to journey from the surface of the Sun to Earth. This means that if the Sun were to suddenly vanish, we wouldn't know about it for over 8 minutes. We'd still see it shining in the sky, completely unaware that it was already gone. It's a mind-bending thought that reminds us we are always looking at a slightly delayed version of reality, a little piece of the past. Did you know that right now, as you're watching this, you're hurtling through space at an astonishing speed? It's true. Our planet, Earth, is zooming around the Sun at a blistering 107,000 kilometers per hour. And that's not all. It's also spinning on its axis. If you were standing at the equator, you'd be moving at about 1,270 kilometers per hour. That's faster than most commercial airplanes. It is mind-boggling to think that we're all on this incredible cosmic joyride without even feeling it. And while we're on this journey, we're constantly being showered with gifts from outer space. Every single day, about 100 tons of tiny interplanetary particles, basically space dust, rain down on our planet. Most of it is microscopic, remnants of comets and asteroids from billions of years ago. So, the next time you see a layer of dust, remember that some of it might just be stardust that has traveled across the solar system to land right there. It's a constant, gentle reminder of our connection to the wider cosmos. But space isn't all friendly stardust. It's also filled with dangerous solar radiation, a constant stream of charged particles flowing from the Sun. So, what protects us from this cosmic onslaught? We have our very own planetary shield, Earth's magnetic field. This invisible force field, generated by the molten iron core deep within our planet, deflects most of the harmful solar wind. Without it, our atmosphere would be stripped away, and life as we know it simply wouldn't be possible. It's our planet's unsung hero, silently protecting us every second of every day. Sometimes, though, this shield puts on a spectacular show. When particles from the Sun do get caught in our magnetic field, they are funneled towards the poles. There, they collide with atoms and molecules in our atmosphere, like oxygen and nitrogen. These collisions excite the atoms, causing them to release energy in the form of light. The result? The breathtaking aurora borealis, or northern lights, and the aurora australis in the south. It's a celestial dance of green, pink, and violet light, a beautiful side effect of our planet defending itself. It's nature's most incredible light show, powered by the Sun itself. Now, let's talk about our atmosphere, the blanket of air that makes our world livable. When you look up, the blue sky seems to end. But where does space actually begin? The line is a bit blurry. While most of our air is within the first 50 kilometers, the atmosphere technically extends much, much farther out for about 10,000 kilometers. That's a vast, tenuous envelope of gas that gradually thins out until it merges with the vacuum of space. This extended atmosphere is where we see those beautiful auroras and where many satellites make their home. Speaking of satellites, let's talk about the incredible speeds they travel at. To stay in low Earth orbit, An object has to move extremely fast to counteract gravity's pull. We're talking about speeds of around 28,000 kilometers per hour. To put that into perspective, that's more than 10 times faster than a speeding bullet. These satellites are constantly falling towards Earth, but they're moving so fast sideways that they continuously miss it, circling the globe in about 90 minutes. So, the next time you see a satellite streaking across the night sky, remember you're witnessing an object outracing a bullet high above your head. Now let's get down to Earth, or rather, down to gravity. It's the force that keeps our feet on the ground and our planet orbiting the sun. But gravity isn't constant everywhere. It follows what's called an inverse square law, which is a fancy way of saying that the farther you get from the center of the Earth, the weaker its gravitational pull becomes. This is why astronauts in orbit feel weightless. They're not free from gravity, but they are in a constant state of free fall around the Earth, far enough away that its pull is significantly weaker. This slight variation in gravity even has an effect right here on the surface. Because the Earth is spinning, it bulges slightly at the equator. This means the equator is a little farther from the Earth's center than the poles are. Combine this with the centrifugal force from the rotation, and the result is that you actually weigh slightly less at the equator than you do at the poles. The difference is tiny, less than 0.5%, so don't plan any weight loss trips just yet. But it's a fascinating quirk of living on a spinning, imperfect sphere. And speaking of imperfections, let's clear up a common misconception about Earth's journey around the sun. We often see diagrams showing a perfectly circular path, but that's not quite right. Earth's orbit is actually a slight ellipse. This means that our distance from the sun changes throughout the year. At one point, called perihelion, we're a bit closer, and at another point, aphelion, we're a bit farther away. It's interesting to note that this slight variation in distance isn't what causes our seasons. The seasons are caused by the tilt of Earth's axis. This elliptical path is just another subtle, beautiful detail in the intricate dance of our solar system. It's a dynamic, complex, and utterly fascinating world, full of wonders that we're only just beginning to understand. Let's start with a planet we all know and love, Saturn. You know it for its incredible rings, right? But here's a fun fact that sounds like it's straight out of a cartoon. Saturn is so big you could fit 764 Earths inside it, but it's actually the least dense planet in our solar system. In fact, it's less dense than water. So, if you could find a bathtub gigantic enough, and I mean absolutely colossal, Saturn would actually float. Imagine that, a floating planet bobbing around in a cosmic tub. It's a mind-bending image, isn't it? Now, let's talk about the star of our show, literally, the sun. It's the center of our solar system, the source of our light and warmth, and it's just massive. We often think of the solar system as this huge collection of planets, moons, asteroids, and comets, and it is, but when you look at the numbers, you get a whole new perspective. The sun alone accounts for a staggering 99.86% of all the mass in the entire solar system. Everything else, Jupiter, Earth, all the other planets, all the moons, all the space rocks, all of that is just the remaining tiny fraction. We're all just little specks of dust orbiting a colossal star. It really puts our place in the universe into perspective. Speaking of planets, let's hop over to our rusty red neighbor, Mars. We see it as the red planet, and its daytime sky is a pale, pinkish-red color because of all the dust in its thin atmosphere. But when the sun sets on Mars, something truly magical happens. The sunset isn't red or orange like ours, it's blue. A brilliant, ethereal blue. The fine dust particles on Mars scatter the red light forward, away from the setting sun, allowing the blue light to penetrate directly to an observer's eye. So, while we enjoy our golden hour, a rover on Mars might be watching a beautiful blue twilight. It's like a little piece of Earth's sky, but on another world. Think that's cool? Let's talk treasure. Forget gold mines on Earth, because space has something even better. Diamonds. There's a planet out there, about 40 light-years away, called 55 Cancri E. It's a super-Earth, meaning it's rocky like our planet, but much bigger, about twice the size and 8 times the mass. And scientists believe that a huge portion of this planet, maybe even a third of its entire mass, is made of pure diamond. Imagine a world with mountains of diamond, shores of diamond dust. It's a real-life treasure planet, a glittering jewel in the cosmos that makes all the riches on Earth look like pocket change. But the wonders don't stop there. Let's stay in our own solar system and visit Jupiter, the king of planets. It's a gas giant with swirling storms, but its moons are where things get really exciting. One of its most famous moons is Europa. From the outside, it looks like a cracked, icy cue ball. But underneath that frozen shell, scientists have strong evidence to suggest there's a massive, saltwater ocean. An ocean that could contain more than twice the amount of water in all of Earth's oceans combined. And where there's liquid water, there's the tantalizing possibility of life. Could there be strange, alien creatures swimming in the dark, hidden oceans of Europa? It's one of the most compelling questions in our search for life beyond Earth. If you thought a diamond planet was wild, get ready for diamond rain. Let's travel to the far reaches of our solar system, to the icy blue giant, Neptune. The atmosphere here is made of hydrogen, helium, and methane. Under the extreme pressure deep inside the planet, thousands of miles below the cloud tops, scientists theorize that the methane molecules are broken apart. The carbon atoms then get squeezed together, forming solid diamonds. These newly formed diamonds are heavier than the surrounding material, so they slowly rain down through the planet's slushy interior, like hailstones in a terrestrial storm, but made of pure diamond. It's literally raining riches on Neptune. And if you thought 55 Cancri E was the ultimate diamond, let's talk about an entire star. Yes, a star made of diamond. Astronomers found a white dwarf star, which is the superdense core left over after a star like our Sun dies. This particular one, named BPM 37093, nicknamed Lucy, after the Beatles song, has cooled and crystallized. What's it made of? Carbon. What do you get when you crystallize carbon under immense pressure? A diamond. This star is essentially one gigantic cosmic diamond, estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. It's the biggest diamond in the known universe. Let's zoom back in a bit and talk about moons. We have 1. Mars has 2. But some planets are just moon hoarders. Take Saturn, for example. For a long time, we thought it had around 83 moons. But recent discoveries have pushed that number way up. As of the latest counts, Saturn has a confirmed 146 moons, and Jupiter is right there with it, boasting nearly 100 known moons. These planets are like their own mini-solar systems, with a complex dance of dozens upon dozens of satellites orbiting them. It's a celestial family portrait that keeps getting bigger and bigger as our telescopes get better. Now, let's think about time. We're used to our 24-hour day, a nice, steady rhythm. But out in space, time gets weird. Let's go back to Jupiter. This behemoth of a planet, more than 1/300 times the volume of Earth, spins on its axis incredibly fast. A day on Jupiter, one full rotation, takes less than 10 hours? Imagine that. Your workday would be over in about 4 hours, and you'd have 2 sunrises and 2 sunsets in the time we have 1. It's a dizzying pace for such a gigantic world. It shows just how different the basic rhythm of life could be on another planet. Let's address a classic sci-fi trope. You know those epic space battles in movies, with giant explosions and roaring starship engines? Well, I hate to break it to you, but space is completely, utterly silent. Sound is just a vibration traveling through a medium, like air or water. But space, for the most part, is a vacuum. There are no molecules packed together to carry those vibrations. So, if you were floating right next to a star as it exploded, you wouldn't hear a thing. It would be a silent, spectacular light show. A silent universe. It's a peaceful, yet slightly eerie thought, isn't it? The cosmos is full of unimaginable violence and beauty, all happening in perfect silence. From floating planets and blue sunsets to diamond rain and silent explosions, the universe is a place of endless wonder. Every new discovery just opens up 100 more questions. What we know is just a tiny drop in a vast cosmic ocean of mysteries. And that's what makes it so exciting. Ever wondered what would happen if you were suddenly exposed to the vacuum of space without a suit? Forget what you've seen in the movies. You wouldn't instantly explode into a million pieces. The reality is far more chilling, but less dramatic. The lack of air pressure would cause the gases in your body to expand, and the moisture on your tongue and in your eyes would boil away. But the immediate fatal problem? Suffocation. With no oxygen, you'd lose consciousness in about 15 seconds. It's a terrifying thought, a stark reminder of how fragile we are outside our planet's protective blanket. Speaking of things from outside our neighborhood, let's talk about a mysterious visitor. In 2017, astronomers spotted something truly unique passing through our solar system. It was long, thin, and tumbling end over end. They named it Oumuamua, which is Hawaiian for a messenger from afar arriving first. This wasn't just another asteroid or comet from our own cosmic backyard. Spectral analysis showed it came from another star system entirely, making it the very first interstellar object ever detected by humans. It was like a postcard from another galaxy, a brief, tantalizing glimpse into the vast, unknown universe beyond our own. Oumuamua has since left our solar system, continuing its lonely journey through the cosmos, leaving us with more questions than answers. While space travel seems glamorous, it takes a serious toll on the human body. One of the biggest challenges astronauts face is the loss of bone density. Here on Earth, the constant pull of gravity puts stress on our skeletons, which signals our bodies to maintain strong bones. But in the microgravity environment of space, this signal is lost. Without that constant gravitational load, the body thinks it doesn't need strong bones anymore and starts to break them down. Astronauts can lose about 1 to 2% of their bone mass for every month they spend in space. To combat this, they have to exercise for hours every single day on special machines designed to mimic the effects of gravity. It's a constant battle to trick their bodies into staying strong, a testament to the incredible adaptations required for us to live beyond our world. Now, here's a bizarre phenomenon that sounds like science fiction: cold welding. If you take two pieces of the exact same type of metal, say two clean, flat pieces of aluminum, and touch them together here on Earth, what happens? Nothing. They just sit there. That's because our atmosphere coats them with a microscopic layer of oxidized material, preventing them from fusing. But in the vacuum of space, there's no air and no oxidation layer. So, if you press two pieces of the same metal together, their atoms have no way of knowing they are separate pieces. The atoms from one piece will happily bond with the atoms of the other, fusing them together into a single, solid piece of metal. This isn't a theory. It's a real problem that spacecraft engineers have to account for. They have to be careful with moving parts and use different materials or special coatings to prevent components from unexpectedly welding themselves solid. Ready for some wild space weather? Imagine a planet where the forecast calls for sideways rain made of glass, flying at speeds over 4,000 miles per hour. Welcome to HD 189733b, a gas giant located about 63 light-years away. This planet has a stunning deep blue color, reminiscent of Earth. But don't be fooled by its beauty. Its atmosphere is scorching hot, over 1,800 degrees Fahrenheit, and filled with silicate particles, the building blocks of glass. Fierce, high-speed winds whip these particles around the planet horizontally, creating a deadly storm of glass shards. It's a world that is as beautiful as it is terrifying, a perfect example of the extreme and alien environments that exist out there in the galaxy. Let's dive into one of the most mind-bending concepts in cosmology: black holes. We know them as cosmic vacuum cleaners, objects with gravity so intense that not even light can escape. But what if they're more than just points of no return? Some physicists and theorists propose a truly radical idea, that black holes could be doorways or portals to other universes. According to this black hole cosmology model, the matter that falls into a black hole isn't destroyed. Instead, it's pushed out the other side into a brand new baby universe. This could mean our own universe was born from a black hole in a much larger parent universe. It's a fascinating, almost philosophical idea that challenges our understanding of reality, suggesting a multiverse of cosmic proportions, with black holes acting as the cosmic gateways between them. It's still highly speculative, but it pushes the boundaries of our imagination. We already touched on cold welding, but it's so fascinating it's worth another look. This process of two similar metals fusing together in a vacuum is a prime example of how differently physics works outside of Earth's atmosphere. The atoms at the surface of each piece of metal are just looking for something to bond with. When they come into contact with atoms of the same kind, they don't hesitate. It's an instant, permanent fusion. This has been a known issue since the early days of space exploration. The first Soviet cosmonauts even reported that some of their equipment was getting stuck. Engineers now use alloys or treat metal components to prevent this unwanted bonding. It's a subtle but crucial detail that makes modern space travel possible. The universe is full of these little surprises that force us to rethink our assumptions about how the world works. Have you ever wondered what space smells like? Astronauts who have been on spacewalks often report a very distinct odor when they return to the airlock and remove their helmets. They describe it as a smell like seared steak, hot metal, or even welding fumes. But what about the broader galaxy? If we could somehow take a whiff of the center of the Milky Way, what would we smell? According to astronomers studying a giant dust cloud called Sagittarius B2, the answer is surprisingly pleasant. This cloud is rich in a chemical called ethyl formate, which is the same compound that gives raspberries their flavor and, fascinatingly, has a smell similar to rum. Another chemical present is acetaldehyde, which has a scent like burnt sugar. So, the heart of our galaxy might just smell like a cosmic dessert, burnt sugar and rum. It's a whimsical thought, isn't it? Now, let's talk about the lighthouses of the universe. Quasars. A quasar, short for quasi-stellar radio source, is an incredibly luminous and distant object. They are essentially the super-energetic cores of young galaxies, powered by supermassive black holes feeding on enormous amounts of gas and dust. As this material spirals into the black hole, it heats up and releases an astonishing amount of energy, creating a beacon of light that can outshine entire galaxies. A single quasar can be hundreds, or even thousands, of times brighter than the whole Milky Way with its hundreds of billions of stars. Because they are so bright, we can see them from billions of light-years away, allowing us to peer back into the early history of the universe. They are the most brilliant objects we know of, shining across cosmic time and space. According to Einstein's theory of general relativity, gravity is not a force, but a curvature of spacetime caused by mass and energy. The more massive an object, the more it warps the spacetime around it. Some galaxies and galaxy clusters are so incredibly massive that their gravitational pull is strong enough to bend the path of light that passes by. This phenomenon is called gravitational lensing. When light from a distant galaxy passes by a massive cluster on its way to Earth, the light is bent and magnified, creating distorted, stretched, or even multiple images of the background galaxy. It's like using a cosmic magnifying glass. Astronomers use this incredible effect to study distant galaxies that would otherwise be too faint to see, giving us a deeper look into the far reaches of the universe. The cosmos is a place of breathtaking wonder and mind-boggling extremes. Imagine this. Some of the twinkling lights you see up there are from stars so far away that their light began its journey to your eyes long before dinosaurs roamed the Earth. Yes, you heard that right. When you gaze at the stars, you're not just looking at a beautiful celestial canvas, you are literally looking back in time. The light from a star a million light-years away shows you what that star looked like a million years ago. It's like having a cosmic time machine, and all you need are your own two eyes. This ability to peer into the past lets us see the universe as it was, not as it is. It's a fundamental concept in astronomy. The farther we look, the further back in time we see. This is how we've been able to piece together the history of our cosmos. And speaking of how far we can look, let's talk about the sheer scale of it all. The part of the universe that we can see, what we call the observable universe, is estimated to be about 93 billion light-years in diameter. To put that in perspective, a single light-year is nearly 6 trillion miles. Wrap your head around that for a second. It's a distance so vast that it's almost impossible for our human brains to truly comprehend. And that's just the part we can see. What lies beyond that edge? The honest and perhaps most exciting answer is, we don't know. It could be more of the same, stretching on infinitely, or it could be something completely different, something beyond our current understanding of physics. The mystery is part of the magic. So, how far back can we look? What's the oldest thing we can see? We can actually see the baby picture of the universe. It's called the Cosmic Microwave Background Radiation, or CMB. This isn't light from a star, but rather the faint leftover glow from the Big Bang itself. It's the afterglow of creation, the very first light that was able to travel freely through space about 380,000 years after the universe began. When we map this radiation, we're seeing a snapshot of the universe when it was just an infant, a hot, dense soup of particles. These tiny temperature fluctuations in the CMB were the seeds that eventually grew into the vast structures we see today, like galaxies and galaxy clusters. It's the oldest story ever told, written in microwaves across the entire sky. Now, here's where things get even stranger. Not only is the universe incomprehensibly vast, but it's also getting bigger every single second. And it's not just expanding. The expansion is accelerating. Galaxies are moving away from each other, and the farther away they are, the faster they're receding. Some of the most distant galaxies we can observe are flying away from us at speeds approaching the speed of light. This accelerating expansion is one of the biggest puzzles in modern cosmology. Scientists believe it's driven by a mysterious force called dark energy, which seems to make up about 70% of the entire universe. We can't see it, we can't detect it directly, but we see its effects pushing everything apart. It's as if the universe has its foot on the gas pedal, and we have no idea who's driving. This idea of a vast, expanding cosmos naturally leads to some even more mind-bending theories. What if our universe isn't the only one? This is the concept of the multiverse. The theory of cosmic inflation, which explains the very early, rapid expansion of the universe, also suggests that this process could have happened over and over again, creating countless bubble universes, each with potentially different physical laws and constants. Our universe would be just one bubble in an infinite cosmic foam of other universes. Think about that. An infinite number of realities, an infinite number of possibilities playing out simultaneously. While we have no direct evidence for the multiverse yet, it's a mathematically plausible outcome of our best theories about the universe's origins. It takes the feeling of being small and multiplies it by infinity. And where could we find a gateway to these other potential universes? Some physicists have a radical idea: black holes. We typically think of black holes as cosmic vacuum cleaners, objects with gravity so strong that nothing, not even light, can escape. But what happens inside? According to Einstein's theory of general relativity, at the center of a black hole is a singularity, a point of infinite density where the laws of physics as we know them break down. Some speculative theories propose that these singularities could be bridges, or wormholes, connecting our universe to another, or even a different point in our own space-time. Could a black hole be a one-way door to a whole new reality? It's a concept straight out of science fiction, but it's one that a small but serious group of physicists are exploring. The universe is already stranger than we can imagine. Perhaps it's even stranger than we can imagine. All of these incredible phenomena, the expanding universe, black holes, the journey of light, are governed by a fundamental yet bizarre property of the cosmos, the fabric of space-time itself. Albert Einstein showed us that space and time are not separate, static concepts, but are woven together into a single, four-dimensional continuum. And this fabric isn't rigid. It can bend, stretch, and warp in the presence of mass and energy. This is what we feel as gravity. A planet orbiting a star is like a marble rolling around a bowling ball placed on a trampoline. The star's mass creates a dip in space-time, and the planet follows that curve. And when massive objects like black holes collide, they send out ripples in this fabric, like a pebble dropped in a pond. These are gravitational waves, and we've actually detected them here on Earth, opening a brand new window to observe the most violent and energetic events in the cosmos. Every single atom in your body was forged in the heart of a star. You are, quite literally, made of stardust. Think about that for a second. The calcium in your bones, the carbon in your muscles, the oxygen you're breathing right now, all of it was created inside a stellar furnace billions of years ago. These elements didn't just magically appear on Earth. They were cooked up under immense pressure and heat inside massive stars. When these stars reached the end of their lives, they didn't just quietly fade away. They exploded in spectacular events called supernovae, cosmic fireworks of unimaginable power. These explosions were so violent that they scattered the newly created elements across the vastness of space. Take the iron in your blood, for example. The very element that carries oxygen to every cell in your body, giving you life and energy, has an origin story of cosmic proportions. That iron was born in the final, fiery moments of a dying star, a star that lived and died long before our own sun even existed. So, the next time you get a paper cut and see a drop of red, remember you're looking at the ancient remnants of a supernova. You carry the ghost of a star within you. This isn't just poetry, it's the grand, interconnected story of the cosmos. For eons, these star-forged elements drifted through the interstellar medium as vast clouds of gas and dust. Over immense timescales, gravity began to pull this material together. It swirled and condensed, forming new stars and new planetary systems. Our solar system, our sun, our planet Earth, they are all second or even third-generation creations, built from the recycled ashes of long-dead stars. So, when you look up at the night sky, you're not just an observer looking out at a separate, distant realm. You're looking at your own cosmic family tree. You're seeing your origins written in light across the canvas of space-time. Those twinkling points of light are the stellar factories that created the very building blocks of your existence. The universe doesn't just surround you, it is fundamentally inside you. Let's bring it even closer to home. With every breath you take, you inhale about 1 billion atoms. And here's the mind-blowing part. Many of those atoms, the nitrogen, the oxygen, have been around for an incredibly long time. They have cycled through countless forms, been part of rocks, oceans, plants, dinosaurs, and now, for a brief moment, they are part of you. Some of these atoms are older than the sun itself, remnants from the primordial cloud that formed our solar system. You are breathing in ancient history. This realization has a powerful effect. It teaches us a deep and profound humility. In the face of the universe's sheer scale and age, our individual lives, our daily worries, our triumphs and tragedies can seem incredibly small. We are fleeting sparks in a cosmic ocean. But this isn't a reason to feel insignificant. On the contrary, it's a reason to feel incredibly special. Because in this vast, seemingly indifferent universe, we exist. We, collections of stardust, have somehow woken up. We have evolved to a point where we can look back out at the cosmos and begin to understand our own origins. The famous astronomer Carl Sagan said it best. We are a way for the cosmos to know itself. Think about that. The universe, through us, has developed consciousness. The stardust has become self-aware. We are the universe's way of looking at itself, of marveling at its own beauty and complexity. What a privilege that is. This perspective also fuels an endless, unquenchable curiosity. When you realize the universe is not just out there, but also in here, you can't help but want to know more. It ignites the explorer within us, and we have so much left to explore. Humanity, with all our telescopes and space probes, has barely scratched the surface. The volume of space we have physically visited is minuscule, a tiny fraction of our own solar system, let alone the galaxy or the universe. To put it in perspective, some estimates suggest our species has explored maybe 0.001% of what's out there. We are like toddlers who have just taken our first steps out of the front door with an entire unexplored world waiting for us. Every new discovery, every image from the James Webb Space Telescope is just another page in a book with an infinite number of pages. There are more stars in the observable universe than there are grains of sand on all the beaches of Earth, and we now know that most of those stars likely have planets. The possibilities are, quite literally, astronomical. The night sky itself is a time machine. Because light takes time to travel across space, when you look at the stars, you are seeing them as they were in the past. The light from our nearest star, Proxima Centauri, took over 4 years to reach us. The light from the Andromeda Galaxy? 2.5 million years. You are looking at history written in photons, a story that has been traveling across the cosmos just to reach your eyes. So, the next time you find yourself under a clear, dark sky, take a moment. Feel the cool night air. Look up. See the Milky Way stretching overhead like a celestial river, and remember your connection to it all. Remember that you are not separate from it. The same forces that govern the orbits of galaxies are at play within your own body. The same elements forged in distant stars are coursing through your veins. You are a child of the cosmos, a piece of the universe that has woken up to wonder about itself. Let that thought fill you with awe, with humility, and with an insatiable desire to keep looking up, to keep asking questions, and to never, ever lose your sense of wonder. The greatest adventure is the one we are all on together, the journey to understand our place among the stars. Have you ever looked up at the night sky and wondered just how far humanity has gone? The answers are more staggering than you might imagine. Right now, as you're watching this, a piece of us is sailing through the void between stars. I'm talking about Voyager 1. Launched decades ago, this incredible spacecraft is now in interstellar space. That's more than 24 billion kilometers from Earth. Let that number sink in. To put it in perspective, every single hour Voyager drifts another 61,000 kilometers farther away from us. It's so far out that when NASA sends it a signal, a simple hello, it takes 22 hours for that message to reach it, and it takes another 22 hours for Voyager's reply to travel all the way back to us. A 44-hour round trip for a conversation at the speed of light. It's a testament to human ingenuity, a silent ambassador in the vast cosmic ocean, still phoning home from beyond our solar system. But while Voyager explores the great unknown, we have a bustling hub of human activity much closer to home. Look up. Well, you can't see it with the naked eye most of the time, but orbiting right above us is the International Space Station, or ISS. This marvel of engineering is our home in space, and life aboard the ISS is anything but ordinary. Imagine seeing not one, but 16 sunrises and 16 sunsets every single day. That's what astronauts experience because the ISS orbits the entire Earth every 90 minutes. They are whipping around our planet at an incredible 28,000 kilometers per hour. To give you some context, that is literally faster than a speeding bullet. It's a constant, high-speed journey that provides a unique perspective on our world, a beautiful, fragile blue marble suspended in the blackness of space. The astronauts up there aren't just conducting experiments. They're living on the very edge of human exploration, experiencing a daily routine that is the stuff of science fiction. Now, getting to space has always been the biggest hurdle. For decades, it was astronomically expensive, mainly because we used to throw away our rockets after just one launch. Imagine buying a brand new airplane for every single flight and then ditching it in the ocean. That's essentially what we were doing. But then a company called SpaceX, led by Elon Musk, decided to change the game. They asked a simple but revolutionary question. Why can't we land our rockets and use them again? The answer was the Falcon 9. These are the first orbital-class rockets in history capable of landing vertically after their mission, either back on land or on a drone ship in the middle of the ocean. The sight of these massive boosters descending from the sky and touching down with pinpoint accuracy is one of the most incredible feats of modern engineering. By reusing their rockets, SpaceX has dramatically slashed the cost of space travel. This isn't just about saving money, it's about opening up space for everyone. It makes missions to the ISS, satellite launches, and even future trips to the Moon and Mars more feasible and frequent than ever before. Reusability is the key that's unlocking a new golden age of space exploration, turning what was once a government-only endeavor into a thriving commercial industry. And what do we do once we're in space? We look. We peer deeper into the universe than ever before, trying to answer the biggest questions of all: where did we come from? And are we alone? For over 3 decades, our most powerful eye on the cosmos was the Hubble Space Telescope. Orbiting above the distortion of Earth's atmosphere, Hubble has given us breathtaking views of nebulae, distant galaxies, and the birth and death of stars. It has captured over 1.5 million stunning images that have not only redefined our understanding of the universe, but have also become iconic pieces of art. Hubble showed us the pillars of creation, revealed the age of the universe, and found supermassive black holes at the centers of galaxies. It has been an invaluable tool, a workhorse that has consistently delivered jaw-dropping science. But even legends must eventually pass the torch. Enter the new king of the cosmos, the James Webb Space Telescope. If Hubble was our powerful eye, The Webb is like gaining a whole new sense. It's the largest, most powerful, and most complex space telescope ever built. Its primary mission is to look back in time. Yes, you heard that right. Because light takes time to travel. When we look at distant objects, we're seeing them as they were in the past. The Webb is so powerful it can see the light from the very first galaxies that formed after the Big Bang, over 13.5 billion years ago. It's a cosmic time machine. To do this, it needs to be incredibly sensitive to infrared light, which is the light emitted by the oldest and most distant objects. And here's a cool fact. To be as reflective as possible for infrared light, the Webb's massive, honeycombed mirrors are coated in a microscopically thin layer of pure gold. It's not just for looks, it's for cutting-edge science. The images it's already sending back are revealing a universe that is more dynamic, more crowded, and more beautiful than we ever dared to dream. From Voyager's lonely journey between the stars to the daily ballet of life on the ISS, the revolutionary cost savings from reusable rockets and the time-traveling gaze of the James Webb Space Telescope humanity is pushing the boundaries of what's possible. Each of these endeavors isn't just a technological achievement. It's a piece of a larger human story. A story of curiosity, of a relentless drive to explore, to understand our place in the cosmos. We are living in an extraordinary time for space exploration. The discoveries being made today will be in the history books of tomorrow. What was once science fiction is now becoming science fact, right before our very eyes. The universe is vast and full of wonders, and we've only just begun to scratch the surface. Have you ever wondered how much it costs to dress for space? Get this, a single astronaut suit costs over $12 million. And you know what's even crazier? Half of that price tag, a cool $6 million, is just for the backpack. That backpack isn't just for carrying snacks. It's a portable life support system, a miniature spaceship that keeps our astronauts alive in the harshest environment imaginable. It's an incredible piece of engineering, and it is just the tip of the iceberg when it comes to the mind-boggling technology that has taken us to the stars and beyond. Let's rewind to the golden age of space travel, the Apollo era. To get to the moon, you need a serious amount of power. I'm talking about the Saturn V rocket. To this day, it remains the single most powerful machine ever built by human hands. Imagine a 36-story building that weighs over 6 million pounds, rocketing off the Earth with a thrust equivalent to 160 million horsepower. The sheer sound it produced was so powerful it could literally shake buildings miles away and was registered on seismographs. It was so colossal, so deafening, that it wasn't just a launch. It was an event that shook the very ground we stand on. This behemoth was our ticket to the cosmos, the brute force necessary to break free from Earth's gravity and send humanity on its first interplanetary voyage. It was a symphony of controlled explosions, a testament to what we can achieve when we aim for the heavens. Now, once you're on your way to the moon, you need to land, and for that, the Apollo 11 crew relied on the Apollo Guidance Computer. Here's where things get really wild. The computer that successfully navigated the lunar module, landed Neil Armstrong and Buzz Aldrin on the moon, and brought them home safely, had less processing power and memory than a single photo you'd take on your smartphone today. Let that sink in. We're talking about a computer with about 2 kilobytes of RAM. The high-resolution photo of your cat on your phone takes up more data than the entire operating system that guided humanity to another celestial body. It's an incredible testament to the ingenuity and efficiency of the engineers at the time. They didn't have unlimited power. They had to make every single line of code, every single byte of memory count. It proves that it's not always about having the most powerful tools, but about using the tools you have with brilliance and precision. Speaking of the moon, what happens when you leave a footprint where there's no wind, no rain, and no atmosphere to speak of? It stays. For a very, very long time. The footprints left behind by the Apollo astronauts, the rover tracks, and the discarded equipment are still there, perfectly preserved in the lunar dust. Scientists estimate that these marks of our first visit could last for millions of years. It's a silent, enduring monument to our achievement. Imagine, millions of years from now, long after we're all gone, those first steps could still be visible. A cosmic message in a bottle telling any future visitor, "We were here." It's a humbling and profound thought, that a simple step can echo through eons, a permanent signature on a world beyond our own. But we're not done with the Moon. Not by a long shot. The next giant leap in lunar exploration is already underway. It's called the Lunar Gateway. Think of it as the International Space Station, but instead of orbiting the Earth, it will orbit the Moon. This ambitious project aims to build the first-ever space station in deep space. It will serve as a science laboratory, a communications hub, and a temporary home for astronauts. More importantly, it will be a staging point, a sort of interstellar pit stop for future missions. From the Gateway, we can more easily send astronauts down to the lunar surface for longer stays, and it will be a crucial stepping stone for the even grander ambition, sending humans to Mars. The Gateway isn't just about going back to the Moon. It's about building a permanent human presence in the solar system. Now, let's set our sights on the red planet, Mars. While humans haven't set foot there yet, our robotic emissaries have been exploring it for years. Rovers like Curiosity and Perseverance are geological robots on wheels, and they've accomplished some incredible feats. These car-sized labs have driven dozens of kilometers across the alien terrain of Mars, all while being remotely controlled by scientists and engineers millions of miles away on Earth. Think about the time delay. It can take over 20 minutes for a signal to travel from Earth to Mars. Every command has to be carefully planned and sent, and the rover has to be smart enough to navigate obstacles on its own. They've climbed mountains, explored ancient riverbeds, and analyzed rocks, sending back a treasure trove of data that has completely rewritten our understanding of Mars and its potential for past life. The Perseverance rover, in particular, carries some very special cargo. Tucked away on the rover is a tiny piece of history, a small swatch of fabric from the wing of the 1903 Wright Flyer. This was the airplane the Wright brothers used to make the first-ever powered, controlled flight on Earth. Now, a piece of that very same aircraft is on Mars. It's a beautiful, powerful symbol. It connects the dawn of aviation on our planet to the future of exploration on another. It represents the journey of flight from a few feet above the sands of Kitty Hawk, North Carolina, to the thin, dusty atmosphere of Mars. It's a reminder of how far we've come and a beacon of inspiration for how far we can still go. And speaking of flight on Mars, the Perseverance rover didn't travel alone. It carried a tiny, revolutionary companion, the Ingenuity helicopter. Making Ingenuity fly was a massive challenge. The Martian atmosphere is incredibly thin, less than 1% the density of Earth's. Flying there is like trying to fly at an altitude of 100,000 feet on Earth, something no helicopter has ever done. Many thought it was impossible. But in April 2021, Ingenuity lifted off, hovered, and landed, becoming the first aircraft in history to achieve powered, controlled flight on another planet. It was our Wright brothers moment on Mars. What was planned as a short tech demo of just a few flights turned into a multi-year mission, with Ingenuity flying dozens of times, acting as a scout for the Perseverance rover. It has opened up a whole new dimension for planetary exploration. Our curiosity doesn't stop at planets. We're also reaching out to the ancient relics of our solar system, asteroids. NASA's OSIRIS-REx mission embarked on a 7-year journey to an asteroid named Bennu. After arriving, it didn't just fly by. It carefully descended, briefly touched the surface, and used a robotic arm to grab a sample of rock and dust. This was an incredibly delicate and precise maneuver, executed hundreds of millions of miles from home. Then it began the long journey back and successfully delivered its precious cargo to Earth. Why go to all that trouble? Because scientists believe Bennu is a time capsule. The material it's made of is thought to be older than Earth itself, a pristine remnant from the formation of our solar system over 4.5 billion years ago. By studying these samples, we can unlock secrets about the origins of planets and maybe even the origins of life itself. So, what's next on this grand cosmic checklist? After returning to the Moon and establishing a foothold with the Gateway, the next logical and perhaps most anticipated step is the human exploration of Mars. This isn't science fiction. It's a stated goal. NASA and its international partners are actively developing the technologies needed to send astronauts on the months-long journey to the Red Planet, have them live and work on the surface, and return them safely to Earth. The current timeline aims for the first human missions to Mars to happen sometime in the mid-2030s. Can you imagine? Within our lifetimes, we could see the first human footprints on another planet. It will be a challenge of unprecedented scale, testing the limits of our technology, endurance, and spirit of exploration. It will be the next giant leap, not just for one nation, but for all of humanity. From the price of a backpack to the first flight on another world, the story of space exploration is a story of human ambition, creativity, and our unyielding desire to understand our place in the universe. Picture every single beach on Earth, from the sunny coasts of California to the black sands of Iceland. Now, try to imagine counting every single grain of sand on all of them. It's an impossible number, right? Well, hold on to your hats, because there are more stars in the universe than all those grains of sand combined. Billions and billions of stars, scattered across trillions of galaxies. It's a number so vast, our brains can barely comprehend it. And these aren't just your average twinkling yellow lights. Some stars are absolute monsters, burning so intensely hot that their color isn't yellow or red. It's a brilliant, piercing blue-white. These blue giants are like the rock stars of the cosmos, living fast and shining incredibly brightly. They're a stunning reminder that even something as familiar as a star can come in spectacular and extreme varieties. Now, you've probably heard the famous line, "In space, no one can hear you scream." And for the most part, that's true. The vacuum of deep space is so empty that sound waves have nothing to travel through. It's a profound, absolute silence. But that doesn't mean the universe is quiet. Instead of sound, radio waves whisper through eternity, carrying messages from distant stars and galaxies. These are the secret conversations of the cosmos, traveling for light years across the void. It's like the universe's own private radio station, and we're just now learning how to tune in. But here's where it gets truly eerie. While sound can't travel through a vacuum, it can travel through gas. Recently, NASA managed to capture the sound of a supermassive black hole. They detected pressure waves rippling through a massive cloud of gas surrounding a black hole billions of light-years away and translated them into a note. The result? A ghostly, deep hum, unimaginably lower than anything a human can hear. It's the most distant and ancient note ever detected, a B-flat played across the universe for billions of years. It's like hearing the voice of a cosmic ghost. Let's bring it a little closer to home. Have you ever wondered what space smells like? Astronauts who have returned from spacewalks have actually described it. When they come back inside and take off their helmets, they report a very distinct odor clinging to their suits. They describe it as a mix of gunpowder, hot metal from welding fumes, and even a hint of burnt steak. This bizarre cosmic perfume is thought to come from polycyclic aromatic hydrocarbons, which are molecules that float around in the vastness of space. So, the next time you have a barbecue, you might be getting a tiny whiff of the final frontier. Speaking of our cosmic neighborhood, our own galaxy, the Milky Way, isn't as peaceful as it looks. It's actually a bit of a bully. Right now, the Milky Way is slowly but surely eating smaller galaxies that get too close. It's a process of galactic cannibalism. One of its current victims is a small galaxy called the Sagittarius Dwarf, which is being stretched and pulled apart by our galaxy's immense gravity. Over millions of years, its stars will be completely absorbed into the Milky Way, becoming part of our own cosmic family. It's a dramatic, slow-motion cosmic collision happening right under our noses. Now, let's talk about some of the most extreme objects in the universe. Imagine something so dense that a tiny piece of it has an unimaginable weight. I'm talking about a neutron star. These are the collapsed cores of massive stars, and they are incredibly dense. How dense? Well, if you could somehow scoop up a single teaspoon of neutron star material, that tiny spoonful would weigh more than Mount Everest. Let that sink in. An entire mountain with all its rock and ice packed into a volume smaller than a sugar cube. It's one of the most mind-bending concepts in all of physics. But what about cosmic treasures? The universe has those too, and I mean literal treasures. Astronomers have discovered a planet about 40 light-years away that is truly a gem. It's called 55 Cancri e, and it's believed to be made largely of carbon. Given the immense pressure and temperature on this super-Earth, scientists theorize that a significant portion of it has crystallized into diamond. That's right, an entire planet of diamond, twice the size of Earth. It's a treasure hunter's ultimate fantasy, floating in the cosmic darkness. Let's turn our attention back to the star of our own show, the Sun. It feels so permanent and steady, but it's actually in a constant state of change. The Sun generates energy by fusing hydrogen into helium, and in this process it converts matter into energy. Every single second, our Sun loses about 4 million tons of its mass. That's like vaporizing several aircraft carriers every second of every day. Don't worry though. The Sun is so massive that it has enough fuel to keep burning for another 5 billion years. And while the Sun is losing all that mass, its light is on a constant journey to us. When you step outside and feel the warmth of the Sun on your face, you're experiencing light that started its journey a little while ago. Specifically, it takes light from the Sun just over 8 minutes to travel the 93 million miles to reach your eyes. So, if the Sun were to magically disappear, we wouldn't know about it for 8 minutes. You're always seeing the Sun as it was in the recent past. It's a constant, tiny bit of time travel. Let's talk about what space does to the human body. Being in a microgravity environment has some pretty strange effects. Without the constant downward pull of Earth's gravity, an astronaut's spine can decompress and straighten out. The result? They can actually grow up to 2 inches taller while they're in space. It's a temporary height boost, though. As soon as they return to Earth, gravity goes back to work, and they slowly shrink back to their normal height. It's a small price to pay for touching the stars. And there you have it, a whirlwind tour of some of the most incredible, mind-bending facts about our universe. From diamond planets to the smell of burnt steak in space, the cosmos is weirder and more wonderful than we can possibly imagine. Every new discovery just opens up 1,000 new questions. What a wild and beautiful universe we live in. We all know Jupiter, the big guy of our solar system. But did you know it's a bit of a moon collector? As of the latest count, Jupiter has a staggering 95 confirmed moons orbiting it, and that number keeps growing as our telescopes get better. Imagine looking up from Jupiter and seeing a sky filled with almost 100 different moons. It's like a celestial party that never ends. Each moon is its own unique world, from the volcanic Io to the icy Europa, which might even hide a subsurface ocean. It really makes our one little moon seem a bit lonely, doesn't it? Now, let's hop over to our other neighbor, Venus. This planet is the ultimate rebel of the solar system. While most planets, including Earth, spin counterclockwise, Venus spins backward or clockwise. This is called retrograde rotation. Scientists have a few theories why. Maybe a giant impact knocked it off kilter billions of years ago. But that's not even the weirdest part. Venus spins so incredibly slowly that a single day on Venus, one full rotation, lasts for 243 Earth days. Here's the kicker. Its orbit around the Sun, its year, only takes about 225 Earth days. That's right. A day on Venus is longer than a year on Venus. You could literally celebrate your birthday before the sun sets on the same day you woke up. Talk about a long work day. Feeling a little small yet? Let's zoom out, way out. A common question people ask is, where is the center of the universe? It's a natural thing to wonder. We think of explosions having a center point, right? But the Big Bang wasn't an explosion in space. It was the expansion of space itself. So, the universe has no center. From any point in any galaxy, it looks like everything is moving away from you. Every direction you look, the universe is expanding equally. It means that you, right now, are just as much at the center of the universe as any other point in existence. It's a mind-bending concept that challenges our very perception of place and position in the cosmos. There's no single "you are here" sticker for the universe. Let's talk about something shiny. Where does gold come from? You might think it's just a rare metal from deep within the Earth, but its origin story is far more spectacular. Most of the gold, platinum, and other heavy elements in the universe were forged in one of the most violent events imaginable, the collision of neutron stars. These are the super-dense remnants of massive stars that have gone supernova. When two of these cosmic relics spiral into each other and merge, the resulting explosion, called a kilonova, is so powerful that it creates and flings these precious metals across the galaxy. So, the gold in your jewelry? It was literally born from a cataclysmic stellar death. You're wearing stardust of the most epic kind. Now, for a paradox. Where is the coldest place in the universe? You'd probably guess some distant, dark corner of deep space, far from any star. And you'd be wrong. The coldest known temperature ever recorded wasn't in space, it was right here on Earth, in a laboratory. The cosmic microwave background, the leftover heat from the Big Bang, keeps deep space at a chilly but still above absolute zero temperature of about 2.7 Kelvin. But scientists at places like MIT have used lasers to cool atoms down to just a fraction of a degree above absolute zero, that ES, negative 273.15 degrees Celsius, or negative 459.67 Fahrenheit. This creates a state of matter called a Bose-Einstein condensate, where atoms behave in incredibly strange quantum ways. We've literally created conditions colder than space in a lab. Feeling down? The universe has a smile for you. The Hubble Space Telescope, our eye in the sky, once captured an image of a galaxy cluster that looks just like a smiley face. The cluster, officially known as SDSS J1038 Plow 8049, features two bright galaxies for the eyes and a cosmic arc for the mouth. This arc is a fantastic example of something called gravitational lensing. The immense gravity of the galaxy cluster bends the light from a much more distant galaxy behind it, distorting it into a curve that looks just like a smile. It's a beautiful, happy accident of cosmic physics, reminding us that the universe can be playful and surprising. So next time you're feeling blue, just remember there's a giant smiley face out there in the cosmos. Speaking of feeling blue, let's talk about sunsets. Here on Earth, we're treated to beautiful red, orange, and pink sunsets because our atmosphere scatters blue light more effectively. But on Mars, it's the exact opposite. While the Martian daytime sky is a dusty, butterscotch color, its sunsets are blue. The fine dust in Mars's thin atmosphere scatters red light forward, so when you look towards the setting sun, you see the blue light that's coming more directly from it. The area immediately around the setting sun on the horizon glows with a distinct blue hue. It's an alien, hauntingly beautiful sight, and a perfect example of how the same physics can create wildly different results on other worlds. Now, the astronaut suit. It's more than just a uniform, it's a personal spaceship. One of its most critical jobs is to provide pressure. Space is a vacuum, and without pressure, the liquids in an astronaut's body would literally boil away. So, the suits are pressurized, but they aren't pumped up to match Earth's full atmospheric pressure. That would make the suit too stiff and difficult to move in. Instead, they are pressurized to about 1/3 of Earth's atmospheric pressure. To compensate for this lower pressure, astronauts have to breathe pure oxygen for a few hours before a spacewalk to purge the nitrogen from their bodies and prevent a condition similar to the bends that divers get. It's a delicate balancing act between survival and mobility. Our neighbor Mars. It's home to the largest volcano in the entire solar system, Olympus Mons. This thing is a beast. It's about 3 times the height of Mount Everest and so wide that if you were standing at its base, its peak would be over the horizon. Imagine a volcano so massive you can't even see the top from the bottom. That's the kind of epic scale we're talking about in our own cosmic backyard. Now, let's jet over to the king of the planets, Jupiter. You've probably seen pictures of its famous Great Red Spot, right? Well, that swirling crimson storm is not just big, it's ancient. Scientists believe it's been raging for at least 350 years, and possibly much, much longer. To put that in perspective, this storm is older than the United States, older than the Industrial Revolution, and potentially older than much of recorded human civilization. It's a storm that has outlasted empires. Speaking of iconic features, let's talk about Saturn. Those beautiful shimmering rings are what make it the jewel of the solar system. But here's a sad truth. They're disappearing. Saturn's immense gravity is slowly pulling the icy particles from its rings down onto the planet's surface in a phenomenon called ring rain. Scientists estimate that in about 100 million years, the rings will be completely gone. So, appreciate them while they last, because future astronomers might only read about them in books. Have you ever seen a picture of a comet with a stunning green glow? It's not just for sci-fi movies. This eerie, beautiful light is real. It's caused by the sun's ultraviolet rays breaking down molecules like cyanogen and diatomic carbon in the comet's head, or coma. These molecules then emit a vibrant green light. It's like a natural cosmic neon sign, zipping through our solar system. Let's head back to Jupiter for a moment, because this planet is just full of extremes. We talked about its storm, but what about its lightning? A single bolt of lightning on Jupiter is unbelievably powerful. It can contain 3 times the energy of a typical lightning bolt here on Earth. Just one of these megabolts could theoretically power a small city for a significant amount of time. It's a light show on a truly planetary scale. Now, let's zoom out. Way out. How big is the universe? The part we can see, the observable universe, stretches about 93 billion light-years across. That number is so large it's almost impossible to comprehend. Remember, a single light-year is the distance light travels in a year, about 6 trillion miles. Now multiply that by 93 billion. It's a distance so vast that it makes our entire existence seem like a tiny, tiny speck. And here's something even crazier. Despite the universe's immense size, our exploration efforts have barely scratched the surface. It's estimated that we have explored less than 0.001% of outer space. Think about that. Almost everything, 99.999999% of the cosmos, is still a complete mystery to us. We are like infants just opening our eyes for the first time, with an entire unexplored universe waiting for us. The age of discovery has only just begun. Okay, prepare to have your brain twisted into a pretzel. Some brilliant physicists and cosmologists are exploring a mind-bending idea called the holographic principle. It suggests that our 3-dimensional universe might actually be a projection, a hologram, of information stored on a distant 2-dimensional surface. So, everything we see and experience, from the planet you're on to the stars in the sky, could be an illusion projected from the edge of the universe. Is reality real? Science is still figuring that one out. Let's bring it back to our solar system for a slightly less brain-melty but equally weird fact. How long is a day? On Earth, it's 24 hours. But on Mercury, the planet closest to the Sun, it's a whole different story. A single day on Mercury, from one sunrise to the next, lasts about 1/408 Earth hours. That's nearly 59 Earth days. Can you imagine a morning that lasts for almost a month straight? What is space made of? You might think it's just an empty vacuum, but you'd be wrong. Space isn't empty at all. It's filled with stuff we can't see, touch, or detect directly. Scientists call it dark matter and dark energy. This invisible substance makes up about 95% of the entire universe. The stars, planets, and galaxies, everything we can actually see, is just the 5% of cosmic glitter on top. We are living in a universe dominated by an invisible, mysterious force that we're only just beginning to understand. From giant volcanoes to disappearing rings and a holographic reality, the universe is more wonderful and weirder than we can possibly imagine. Every new discovery just opens up 1,000 new questions. Imagine this: 2 colossal black holes, each with gravity so strong that not even light can escape, spiraling toward each other. When they finally collide, they don't just create a bigger black hole, they unleash a cosmic cataclysm. This merger sends out powerful ripples in the very fabric of reality. We call them gravitational waves, and they literally shake space-time itself as they travel across the universe. It's like a cosmic earthquake, proving Einstein's theories in the most dramatic way possible. Speaking of cosmic collisions, look toward the Andromeda Galaxy. It's our closest major galactic neighbor, a beautiful spiral of stars just 2.5 million light-years away. But don't get too comfortable. Andromeda is hurtling toward our Milky Way at a staggering speed. The good news? The galactic smash-up isn't scheduled for another 4.5 billion years. When it happens, our night sky will be filled with a spectacular, fiery display as 2 galaxies become one. It will be the greatest light show in history, but sadly, none of us will have a front-row seat. Now, let's talk about some of the most extreme objects in the cosmos: neutron stars. These are the super-dense remnants of massive stars that have gone supernova. They are so dense that a single teaspoon of neutron star material would weigh billions of tons. But what's truly wild is their speed. Some neutron stars, known as pulsars, spin hundreds of times every single second. Imagine an object more massive than our Sun, spinning faster than a kitchen blender. They are the universe's ultimate celestial spinning tops. Think the weather on Earth is bad? Let's take a trip to Uranus. On this distant ice giant, the atmospheric pressure is so intense that it can crush carbon atoms and squeeze them into diamonds. Yes, you heard that right. Scientists believe it literally rains diamonds on Uranus. These precious gems form in the atmosphere and then slowly sink toward the planet's core. So, if you're ever looking for a cosmic treasure hunt, Uranus might be your ultimate destination. Just be sure to pack a very, very strong umbrella. And the universe keeps sending us puzzles. Deep in space, astronomers detected a mysterious radio signal that repeats like clockwork, flaring up every 16 days. What is it? A wobbling neutron star? A strange celestial beacon? We still don't know. It's an ongoing cosmic mystery that has scientists scratching their heads. This fast radio burst, or FRB, is a reminder that the universe is still full of unexplained phenomena, broadcasting secrets we are only just beginning to hear. Speed is relative, right? Well, some galaxies take that to an extreme. We've discovered hypervelocity galaxies zipping through space at more than 2 million miles per hour. That is fast enough to escape the gravitational pull of their own galaxy clusters and journey into the vast emptiness of intergalactic space. They are cosmic runaways, flung out by massive gravitational interactions, destined to wander the universe alone. We often think of space as an empty vacuum, but it has weather, and it's far more violent than anything on Earth. Space weather includes powerful solar flares, storms of high-energy radiation, and massive bursts of plasma called coronal mass ejections that are hurled from the Sun. These storms can disrupt satellites, endanger astronauts, and even knock out power grids here on Earth. So, the next time you enjoy a sunny day, remember that our Sun is also capable of some pretty stormy behavior. Here's a concept that might break your brain. The universe is expanding, and the farther away you look, the faster things are moving away from us. At the very edge of the observable universe, the expansion is so rapid that galaxies are receding from us faster than the speed of light. Now, this doesn't violate Einstein's laws, because it's space-time itself that's expanding. Nothing is traveling through space faster than light. It just means there are parts of the universe we will never, ever be able to see or reach. They are forever beyond our cosmic horizon. Life in space is different in so many ways, right down to the simplest human emotions. For astronauts on the International Space Station, crying is a strange experience. Without gravity to pull them down, tears don't fall. Instead, they well up in the eyes, forming a liquid blob that just floats there. It stings and blurs their vision, so they have to wipe the tears away. It's a small but poignant reminder of how deeply our bodies are connected to the pull of our home planet. Let's celebrate a monumental human achievement. For millennia, we were bound to Earth. But in 1977, we sent a messenger to the stars. The Voyager 1 spacecraft, after an epic journey past Jupiter and Saturn, crossed a boundary known as the heliopause in 2012. It officially left our solar system and entered interstellar space, becoming the first human-made object ever to do so. On board is the Golden Record, a collection of sounds and images from Earth, a message in a bottle cast into the cosmic ocean. It is our silent ambassador, carrying the story of humanity to whatever or whoever might be out there. Imagine floating through space and suddenly catching a whiff of rum and a taste of raspberries. It's not a dream. There's a giant dust cloud out there, Sagittarius B2, filled with a substance called ethyl formate. It's the same chemical that gives raspberries their flavor and rum its distinctive smell. So, the heart of our galaxy is basically a giant cosmic cocktail. Who knew? Now let's talk about time. We all wish we had more of it, right? Well, astronauts actually get a tiny bit extra. Thanks to Einstein's theory of relativity, time literally passes slower for objects moving at high speeds and in weaker gravitational fields. This phenomenon, known as time dilation, means that when astronauts return from space, they've aged just a fraction of a second less than everyone back on Earth. Their watches prove it. It's a real-life, albeit very small, fountain of youth. Thinking about the center of our own galaxy, the Milky Way, brings us to something truly massive and mysterious. At the heart of nearly every large galaxy, including our own, lurks a supermassive black hole. Ours is called Sagittarius A. These cosmic titans are so dense that nothing, not even light, can escape their gravitational pull once it crosses the event horizon. They are the anchors of their galaxies, shaping the stars and systems that revolve around them. And if you think a regular black hole is mind-bending, wait until you hear this. Some of these cosmic monsters spin at incredible speeds, approaching the very speed of light itself. Imagine an object with the mass of billions of suns, rotating so fast that it drags the very fabric of space-time around with it. This frame-dragging effect is one of the most extreme predictions of general relativity, turning these spinning black holes into swirling vortices of cosmic power. It's a dizzying thought, isn't it? Let's bring it a little closer to home. We all know the sun is big, but it's hard to grasp just how big. Try this on for size. You could fit approximately 1.3 million planets the size of Earth inside the sun. If the sun were a hollow ball, you could just keep pouring Earths into it until you hit that staggering number. It makes you feel pretty small, doesn't it? Our star is truly the king of our solar system, a colossal ball of fire that dwarfs everything around it. Now, let's play with light. We usually think of light traveling in a straight line, but in space, even light has to obey the rules of gravity. When light from a distant star or galaxy passes by a massive object, like another galaxy or a black hole, its path gets bent. This phenomenon is called gravitational lensing. It's like the universe has its own giant magnifying glass. Sometimes this effect can create multiple images of the same distant object, or distort it into a beautiful arc or ring, known as an Einstein ring. It's a stunning visual proof of Einstein's theories. Speaking of our sun, it won't be around forever in its current form, but don't worry, we've got about 5 billion years left. After it exhausts its hydrogen fuel, it will swell up into a red giant, likely engulfing Mercury, Venus, and possibly even Earth. Then, after shedding its outer layers, all that will remain is its hot, dense core, a white dwarf. This Earth-sized ember will slowly cool and fade over trillions of years, a final, quiet testament to the star that once gave us life. Feeling a little tingle? It might not be your imagination. Right now, as you're watching this, your body is being constantly bombarded by cosmic rays. These are high-energy particles, mostly protons and atomic nuclei, that are blasted across the universe from distant supernovae and other violent cosmic events. They zip through space at nearly the speed of light and pass right through almost everything, including you, even when you're sound asleep. We're all getting a tiny dose of the cosmos, every single second. Let's head over to one of the most beautiful planets in our solar system, Saturn. Famous for its magnificent rings, Saturn has another incredible secret. It's the least dense planet in our solar system. In fact, its average density is less than that of water. So, if you could find a bathtub big enough, and I mean cosmically, ridiculously big, and fill it with water, Saturn would float. It's the only planet that could pull off this party trick. Now, a shocking facts about the Moon. It feels like a constant in our sky, but it's actually making a slow getaway. The Moon is drifting away from the Earth at a rate of about 3.8 centimeters, or 1.5 inches, every single year. This is due to the tidal interactions between the Earth and the Moon. Billions of years ago, the Moon was much closer, and days on Earth were much shorter. As it drifts away, our days are slowly getting longer. So, enjoy our big, beautiful Moon while you can, because it's slowly saying a very, very long goodbye. Picture the universe in its infancy, just a few 100,000 years after the Big Bang. It wasn't the dark, star-studded expanse we know today. Instead, everything, and I mean everything, glowed with a brilliant uniform blue light. This period is known as the Dark Ages, which is a bit ironic because the entire cosmos was filled with this ethereal, bluish glow. It was a universe without stars, without galaxies, just a vast, glowing sea of superheated hydrogen and helium gas. This glow was the afterglow of creation, the first light of the universe, and for millions of years, this was all there was. It's a serene, almost poetic image, isn't it? a universe born in a sea of blue light. So, how did we get from that glowing blue fog to the complex universe we see today? The answer is dust, cosmic dust, to be precise. Now, when you hear dust, you probably think of the stuff you have to clean off your shelves. But in space, dust is the secret ingredient for creation. Over millions upon millions of years, tiny grains of cosmic dust, smaller than a grain of sand, started clumping together. Gravity, the universe's master architect, pulled these tiny particles into bigger and bigger clumps. These clumps grew into pebbles, the pebbles into boulders, the boulders into planetesimals, and eventually, after an unimaginably long dance of cosmic construction, these planetesimals formed the planets we know and love, including our own Earth. So the next time you look at our world, remember that it was built, speck by tiny speck, from the dust of ancient stars. It's the ultimate cosmic recycling program. Now we're all familiar with planets orbiting a star, like Earth orbiting the Sun. It's a stable, predictable cosmic family. But what if a planet had no family? What if it was cast out to wander the cold, dark void of interstellar space all alone? These are the rogue planets, the wandering worlds of our galaxy. Scientists believe there could be billions, maybe even trillions of these starless planets drifting through the Milky Way. They were likely ejected from their home solar systems during chaotic formation periods. Imagine a world with no sunrise, no sunset, just an eternal night sky filled with the distant glitter of unfamiliar stars. It's a lonely, haunting thought, but it reminds us that the universe is far wilder and more unpredictable than we can imagine. These cosmic orphans are out there, silently sailing through the darkness. Speaking of strange things in the dark, let's talk about a sound, or rather, a noise that shouldn't be there. In 2006, a NASA instrument detected something completely unexpected, a mysterious, powerful radio noise coming from the distant universe. It was 6 times louder than anything they predicted. They called it the space roar. The weirdest part? We still have no idea what's causing it. All of our known sources of cosmic radio waves, like ancient stars and galaxies, can't account for this incredible volume. It's as if the universe is shouting, and we can't understand what it's saying. Is it the echo of the very first stars forming? Or something entirely new to science? The space roar remains one of the biggest unsolved mysteries in cosmology, a ghostly signal from the deep, reminding us just how much we still have to learn. To solve mysteries like the space roar, we need better eyes. And right now, humanity's best eye on the universe is the James Webb Space Telescope. This incredible observatory is a time machine. Because light takes time to travel, looking far away in space is the same as looking back in time. The Webb telescope is so powerful it can capture light that has been traveling for over 13 billion years. That means we are literally seeing images of the very first galaxies as they were just beginning to form, not long after the universe emerged from its dark ages. It's like looking at the universe's baby pictures. Every breathtaking image it sends back is a postcard from the dawn of time, allowing us to witness the birth of the cosmos firsthand. This idea of seeing the past isn't just for multi-billion-dollar telescopes. You can do it yourself, tonight. Just go outside and look up at the night sky. The light from the moon? It's about 1.3 seconds old. The light from the sun, though you shouldn't look directly at it, takes over 8 minutes to reach us. The nearest star system, Alpha Centauri, is over 4 light-years away. That means when you look at it, you're seeing it as it was 4 years ago. The Andromeda Galaxy, the most distant object you can see with your naked eye, is 2.5 million light-years away. The light you see from it tonight started its journey when our earliest human ancestors were first walking the Earth. Every single point of light in the night sky is a glimpse into history. You're not just stargazing, you're time-traveling. Let's try to grasp the scale of it all. Our sun is just one star. But how many stars are in our galaxy, the Milky Way? The estimates are staggering, hovering around 200 billion. 200 billion stars. If you were to count one star every single second, it would take you over 6,000 years to count them all. And each one of those stars could potentially have its own system of planets, its own rogue worlds, its own unique story. Our sun, the center of our world, is just a single, average member of an immense, glittering city of stars. It's a humbling perspective that really puts our place in the cosmos into context. Now, for the heavyweights of the universe. In the center of a galaxy called Messier 87, there is a monster, a supermassive black hole that astronomers managed to photograph for the first time in 2019. Its mass is almost impossible to comprehend. It's 6.5 billion times the mass of our Sun. Let me say that again. 6.5 billion suns, all crushed into a single point of infinite density. Its event horizon, the point of no return, is larger than our entire solar system. This is an object with a gravitational pull so immense that nothing, not even light, can escape it. It's a true titan of the cosmos, a force of nature that warps the very fabric of space-time around it. And speaking of space-time, here's a thought that might break your brain a little. We know the universe is expanding. Galaxies are flying away from each other, and space-time itself is stretching. But will it do that forever? Some physicists have a radical theory that time itself might one day stop. According to this idea, the expansion of the universe is linked to the arrow of time. If, for some reason, the expansion were to slow down and eventually stop, time as we know it could freeze. The universe would be locked in a static, unchanging state for eternity. It's a mind-bending concept that challenges our most fundamental understanding of reality. We live our lives by the clock, but the universe itself might one day run out of time. As the universe expands, it also gets colder. Every single second, the overall temperature of the cosmos drops by an infinitesimally small amount. This is a concept known as the heat death of the universe. Over trillions upon trillions of years, all the stars will burn out. All the black holes will evaporate. All energy will be spread out so evenly that no work can be done. The universe will become a vast, dark, and unimaginably cold place, approaching a temperature of absolute zero. It will be a silent, empty void. This isn't going to happen anytime soon, of course, but it's the ultimate, inevitable fate of our cosmos. Have you ever seen the first ever photo of a black hole? It wasn't until 2019 that humanity finally captured an image of this gravitational titan, a supermassive black hole at the heart of the M87 galaxy. This incredible feat, achieved by the Event Horizon Telescope, turned science fiction into science fact, giving us a real look at the edge of space-time itself. It's a testament to human ingenuity and our relentless quest for knowledge. Now, let's journey closer to home, to the king of our solar system, Jupiter. We all know it's big, but did you know its magnetic field is a staggering 14 times stronger than Earth's? This immense magnetic bubble, called a magnetosphere, traps charged particles and creates intense auroras that dwarf anything we see on our own planet. It's a powerful, invisible shield that shapes the environment for light years around it. Speaking of our neighbors, let's talk about Venus. Often called Earth's twin because of its similar size, Venus is anything but hospitable, and its sense of time is completely alien. A single day on Venus, the time it takes to complete one rotation, is 243 Earth days long. To make it even stranger, a Venusian year, the time it takes to orbit the Sun, is only about 225 Earth days. That's right, a day on Venus is longer than its year. Imagine celebrating your birthday before the sun has even set for the day. Many people think of space as a silent vacuum, but that couldn't be further from the truth. While sound waves can't travel, space is humming with electromagnetic whispers. Radio waves, microwaves, and other forms of light travel across the cosmos, carrying information from distant stars and galaxies. If we had radio antennas for ears, the universe would be a symphony of cosmic noise, a constant broadcast from the beginning of time. And that brings us to the oldest sound in the universe, the cosmic microwave background radiation. This isn't just random static, it's the actual afterglow of the Big Bang. About 380,000 years after the universe began, it cooled enough for light to travel freely for the first time. That ancient light has been journeying across space ever since, and today we detect it as a faint microwave glow in every direction we look. It's a baby picture of our universe, a fossil from the dawn of creation. From the beginning of the universe to its end, let's talk about some of the most fascinating objects out there. Pulsars. These are the spinning remnants of massive stars that have gone supernova. They're essentially dead stars that still beat like cosmic hearts. As they rotate, they sweep beams of radiation across space, and when one of those beams points toward Earth, we see a pulse. Some spin hundreds of times per second, making them the most precise clocks in the known universe. They are lighthouses in the cosmic ocean, guiding our understanding of extreme physics. Now, let's venture back to the most extreme places imaginable: black holes. Einstein's theory of relativity predicts a bizarre phenomenon called time dilation. The closer you get to a massive object like a black hole, the slower time passes for you compared to someone far away. This isn't just theoretical. It's been proven with atomic clocks. Near the event horizon of a supermassive black hole, the effect is so extreme that a single hour for you could feel like years, or even centuries, passing for the rest of the universe. It's the ultimate one-way trip through time. If a black hole is a cosmic vacuum, what's its opposite? Theoretically, it's a white hole. While black holes are regions of space-time that nothing can escape, a white hole is a hypothetical region that nothing can enter. Instead of sucking matter in, it spits matter out. No one has ever found a white hole, and they may only exist in the equations of general relativity. But they spark our imagination. Could they be the exit for matter that enters a black hole in another universe? This brings us to the ultimate fate of everything. Just as the universe began with a big bang, some theories suggest it could end in a big crunch. If there's enough mass in the universe, gravity could eventually overcome expansion, pulling everything back together. Galaxies would rush toward each other, merging in a final cataclysmic collapse until the entire universe is compressed back into an infinitely hot, dense point, perhaps even triggering a new Big Bang. It's a cyclical view of cosmic life and death on the grandest scale. We think of our sun as huge, but it's a dwarf compared to some of the titans out there. Take the star UY Scuti, a red hypergiant. It's one of the largest known stars by volume. If you were to place it at the center of our solar system, its surface would extend out past the orbit of Jupiter, completely engulfing Mercury, Venus, Earth, Mars, and the asteroid belt. Our entire inner solar system would fit inside this single, colossal star. It's a humbling reminder of the sheer scale and magnificence of the cosmos.